Okay, so you found the Algebra 1 quick review, and this is for systems of equations, right? Systems of linear equations. And I want to show you some special situations. All right, you must remember the three possibilities with a system. When you got a linear system, the two lines will intersect at one point. That's one possibility. When they do, it's consistent. There is a solution. It's independent because it's a single point solution, and we would give the xy coordinates of that point as the solution. Second possibility, it's the same line. So it's consistent because there is a solution, and the solution is, remember, every point along that line. And so we give the equation of the line as a solution, dependent because it's an infinite set of points along the line. Third possibility, there is no solution because the lines are parallel. There's no point of intersection. All right, so mathematically, using substitution and elimination, we've solved problems that were consistent and independent. They had a point of intersection, and therefore we were able to give the point of intersection. How do we know when it's the other two possibilities? Well, here's what's going to happen. What's going to happen is the variable or variables are going to add out. In other words, they're going to disappear, they're going to add up to 0, and they won't be there anymore. And you have to read what's left to then determine which of these two possibilities the solution is. Okay? So if your variables add out, then it's either consistent dependent or inconsistent. All right, it's pretty easy to read. Just read what's left. If what's left is true, it's consistent and dependent. Give the equation of the line as your solution. If what's left is false, then it's going to be inconsistent. The lines are parallel. There is no solution. Okay, so let's look at these possibilities. All right, I'm going to solve this one by substitution. So let me solve the blue equation for x. And so I get x equals -1 minus 2y. I like to circle that. And I'm going to sub this into the black equation for x. All right, so subbing in -1 minus 2y. Let's distribute my 2. -2, -4y plus 4y equals 12. And look what happens. You see right here, they add out. They add up to 0. And here's where I'm at now. I have -2 equals 12. And this is clearly false. Therefore, what was the situation here? Hey, this one had to be inconsistent, no solution, right? I had a false result. It's inconsistent, no solution. You can write the null set if you want. All right, let me review the elimination method when I show you the other possibility. Okay, so let's suppose we have these two equations. All right, first off, I need to rearrange the blue equation to get it in proper order. I'm going to add a -20x to both sides to get the x in the correct place. And so now we're at -20x plus 15y equals 10. Okay, I need to get coefficients to be equal and opposite. Let me choose the x's. And so therefore, if I multiply the top equation by 5, that will get my x's equal and opposite. So let me rewrite the new black equation. You get 20x minus 15y equals -10. Now look what happens when we add these two equations up. The x's are gone, right? And the y's are gone, and the left side is 0. And guess what? The right side is 0. This is a true result, right? This is true. And so the solution is the equation of the line. This is consistent and dependent, right? We're this solution. And you would have to write one of the equations of the line. I'll take the first one. It was in standard form, 4x minus 3y equals -2. Okay? So special situations. Hey, if your variables add out, if what's left is true, it's going to be consistent and dependent. They're the same line. You write the equation of the line. If what you have left is false, they are inconsistent, no solution. All right, that's the idea.